Hi everyone, welcome to the channel. Today we'll be looking at this problem called add two numbers. If you're new, welcome, and also if you've been here before, welcome again. And what you'll find here is content on software engineering interview questions as well as how to use various technologies. Be sure to like and subscribe if you like and share with others that you think will benefit from this. Without further ado, let's get into it. So for this problem, add two numbers, we're given two non-empty linked lists that represent two non-negative integers, and then the digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. And we assume the two numbers do not contain any leading zero except the number 0 itself. Okay. So here's our two linked lists. 2, 4, 3, and 3, 5, 6, 4. So when we add them, add 2 with 5, so that's why this is 7, and then 4 with 6 is 10. So we have to carry the 1, and we have a 0 here, carry the 1. 3 plus 4 is 7, but we have that carry, so it's plus 1, which gives us 8. So 807, 342, 465. So what we can do here is we can iterate through the two linked lists, each time taking one digit and then adding. Adding the two digits as well as taking into account if there is a carry. So for instance, these two digits, 4 plus 6, there's a carry. So for here, when we do 3 plus 4, we have to not only add these two digits, but also take into account the carry. And so to handle the first two cases, the carry will start initially at 0, and then we'll be adding these numbers. On top of adding these numbers, we want to add to our linked list. And so the strategy with this kind of problem is we can have a head, since we need to return the linked list. Well, we can make the head initially equal to -1, which will serve as a dummy node, and at each point in time when we add the first two digits, we'll make the next first digit sum. In this case, it would be 7, and then when we process the next digit, it would be 0 and then 8. And then we return head.next. Well, head is pointing to -1, and then we will return head.next to return the head, which is 7, so we'll return 708. And as we move through this, we will want a dummy pointer. So we have dummy equals the head, and move the dummy pointer to add to the linked list. So what we said before was we want to take into account carry, add each digit, create new node, add to head, increment pointers in each list, increment pointer of new list. So like we were saying before, we have a carry and then make our dummy node and make the dummy equal to head. So the way we will do those things is to have carry initialized to 0, since when you start you don't have a carry, such as 2 plus 5. There would never be a carry for that, so we initialize that, and then head equals list node. Create the list node object, and we'll do -1, and then we'll make dummy equals to head. it's kind of summarizing these things that we've been saying. All right. Now we do a while loop, and we will continue processing each of the elements in the two linked lists until both linked lists are done. So one thing to take into account is it's possible that the two linked lists are not the same length. So if one is shorter than the other, we still want to proceed until every single element is processed. So we'll continue so long as each pointer on the linked list are not empty. So it'll be L1 or L2, meaning if L1 is longer than L2 and it's not done processing, then we'll continue. If both of them are not done processing, then we'll continue. And then we'll have first to represent the first number, which will be L1.val if L1 is not equal to none, else it will be none. And the second digit to process, very similar to how we do L2, is checking the same exact conditions except just for L2. This way, if L1 equals to none, right here, check this condition first, then we'll just return none and then assign that to first. Oh, sorry, I should not be assigning none. I should be assigning 0. Since if one of the linked lists is none, it means that the list is done processing. So if first is longer than second, then first will become none. If first is longer than second, then second will become none before first. And so we always want to add 0 to whatever value is in first, and vice versa. So if second is longer than first, then first will become none before second becomes none. And so one point we'll check one of the linked lists and it will be none, and we want to have 0 added to the value. That way we won't have an error where none adds to a digit. If they're both not none, then we will be doing normal addition as this example, such as 2 plus 5. And then we take into account the sum, which we also take into account the carry. Now, we'll say the carry is 1 if cur is greater than 9, else it is 0. The current digit that we are summing for the two linked lists will not have a carry for the future digit or for the next digit if the sum is not greater than 9. Now we can append, such as here. We have right now, we have this implemented, and we want to make the next equal to the current sum. So right now we get, if we run this example, we check first and second, they equal to 2 and 5. Then we do cur is first plus second plus carry, so it'll be 2 plus 5, which is 7. So right now this cur is 7, and then we say carry is will be 0. And then now we want to assign 7 to point to after the head. So right now dummy points as well to head, which points to the list node -1. So we say dummy dot next equal list node, and then we do cur mod 10, because if the cur was greater than 10, we just want to assign the current digit first, and then we will adjust the carry later. And then we move the pointer for dummy. So once we have 7 written, we don't want dummy to still point to -1. This star will denote where dummy is pointing to, because if we continue that without incrementing this, then the next digit will just overwrite this digit. So we want to move this. Now dummy points to this. That way next time dummy writes, it will add here, and then we'll add 0. So yeah. And then the next thing is we need to move the 2 pointers in each of the linked lists, because right now L1 points to 2, and then L2 points to 5. But now after we're done processing, we want L1 to point to 4 and then L2 to point to 6. So the way to do that is to do L1 equals L dot 1 dot next and L2 equals L2 dot next. But there's one catch, which is the same thing as here. We have to make sure that L1 and L2 are not none, because if they are none, we want to keep them pointed to none. Since if you do none dot next, it will error, and that's not what we want. All right. So we see if we proceed from here that L1 points to 2, L2 points to 5. Those are both not none. So now we move to the next. So L1 points to 4, L2 points to 5, points to 6. And then we go to here. First will equal to 4, second will equal to 6. And then when we do first plus second plus carry, we get 4 plus 6 plus 0, which is 10. And then we say carry 1 if carry is greater than 10, greater than 9. And it is. So carry is now 1. And then we say dummy.next equals cur mod 10, which will give us 0. So we say dummy.next equals 0, and so that's where we apply this. And then we check if the two are 0 or not, are none. So the next of 4 is 3, next of 6 is 4, so both of them are not equal to none. So now they point to 3 and 4 for L1 and L2 respectively. And we also move the dummy.next pointer, which I should have mentioned before, moving those two pointers. And so now the dummy pointer points there. And then we get first and second, which is 3 and 4. Then we add first plus second plus carry, which is carry is 1. So it's 1 plus 3 plus 4 gives us 8. And then carry is 0 because 8 is not greater than 9. And then dummy.next is 8 mod 10, which is 8. So looking at where the dummy pointer is, now we have that. And then we move the dummy pointer just in case we have to process another thing, but it's the end of the list. And so now both L1 and L2 are none, since 3 points to none and 4 points to none. As we can see here, the object creation, self.next is automatically assigned to none. Now once we move there, we're ready to think about one more edge case, which is it's possible that the end, the last two digits, they have a carry still. So let's say that these two digits, it could be 7 and 4, in which case, well, simple case would be if it's 3 and 7. So if this was a 3 and this was a 7, then we would have one extra digit since it would equal to 10. And so to take that into account, if carry is not 0, then we will need to add another then we will need to add the element with 1, which is the carry, to the next point in the linked list to return. So if carry greater than 0, dummy.next equal this node 1, and then return head.next. All right, let us check to see if this works. All right, great. Looks like it works. And we talk about the runtime, which is if we have n elements, where n is the longest of the two linked lists, then it would take O of n to do this while loop. And then, yeah, so that would be the runtime. Since all these operations are constant time, addition, modding things, creating an object. And the space complexity is constant space because we are not storing any space. I mean, yes, we do make one dummy node, but that doesn't scale with our input. We'll always have just one dummy node, and the linked list that we create is what we return. So yeah, so the dummy node eventually will get garbage collected, and then everything after is what we return. And so yeah, the space complexity will be constant. And yeah, that's the problem for today. Hope you guys had as much fun as I did and also learned. I hope to see you all in the next one, and please follow me on social media and like and subscribe if you enjoy this content. Lastly, I hope you all enjoy the rest of your day.